The question over here is, in the form of dichromate, Cr6 is a strong oxidizing agent in acidic medium, but molybdenum in +6 oxidation state in MoO3 and tungsten in +6 oxidation state in WO3, they are not strong oxidizing agent. Why? So the answer to this particular question is कि MO in +6 oxidation state and tungsten in +6 oxidation state, they are more stable than chromium in +6 oxidation state. Option B is the right answer. Also, higher oxidation states of heavier members of group 6 of transition series, they are more stable. Now listen to me very carefully. In D block elements, higher oxidation state, I just want to write and make a note over here. Higher oxidation states are more stable. Higher oxidation states are more stable for heavier elements. I'm talking about D block elements. Remember this particular thing. Higher oxidation states are more stable for heavier elements. I'm talking for D block elements. So molybdenum and tungsten, if I talk about molybdenum and tungsten, they are heavier elements. Fine. So they are more stable in +6 oxidation state. Also, as we move down the group in the periodic table, the stability of the elements with the higher oxidation state increases. Clear? ये मैंने दो बातें इंपॉर्टेंट बताई हैं. अब याद रखिएगा एक और इम्पॉर्टेंट बात, जो हमारा क्रोमियम है +6 ऑक्सीडेशन स्टेट के अंदर, इट इज़ नॉट द ओनली स्टेबल ऑक्सीडेशन स्टेट ऑफ क्रोमियम. इट इज़ नॉट the only stable oxidation state of chromium. Fine. So chromium in +6 oxidation state gains electron to reduce itself to its other stable oxidation state, other stable oxidation state like chromium in +3 oxidation state, thereby oxidizing the other species. Electronic configuration chromium की क्या है? It is argon 3d5 4s1. Talking about the electronic configuration of chromium in +3 oxidation state, it is argon 3d3. So this makes it half filled. किस लेवल पे? T2G लेवल पे. T2G लेवल पे एक तरह से ये हमारी हाफ फिल्ड इलेक्ट्रॉनिक कॉन्फ़िगरेशन हो गई. इसका मतलब ये हुआ कि जो हमारे सब ऑर्बिटल्स हैं dxy, dyz एंड dzx, they are half filled. I think you got my particular point, huh? So it's an oxidizing agent. Now, when we are moving down the group, stability of, as I already told you, heavier transition metals in their higher oxidation state, stability of heavier transition elements in their higher oxidation state increases. This is due to the similarity of the energy of the d orbitals with the outer s orbitals. Hence, the d orbital are more available for bond formation. Now, molybdenum and tungsten जो हैं, they are heavier elements. So, these elements are more stable in the +6 oxidation state. Thus, these metals have little or no tendency to get reduced. भाई ये molybdenum and tungsten ये actually stable हैं in the higher oxidation state +6. तो they have, I'll say, no tendency, rather I should say, or a very little tendency to get reduced to their lower oxidation state. That's why MO6 and W6, they are not strong oxidizing agent, because oxidizing agent is the agent that oxidizes the other species and itself get reduced. Hence, molybdenum and tungsten in +6 oxidation state, they are more stable in comparison to chromium in +6 oxidation state. And so, option number 2 and 3 is the right answer for the question.